Okay, this is AP Calculus Lecture 5.10b. In this lecture, we will talk about integrating hyperbolic functions, and it almost always involves u substitution. You will want to have your formula sheet ready to go, and we'll be looking at the antiderivative section of the sheet. And in addition, at the end of the lecture, we're going to look at the inverse derivatives. So hyperbolic functions also have inverse hyperbolic functions. We'll look at how to do the derivatives of those. And fortunately, you do not have to remember the formulas. Okay, so our first one is example 38 from page 400. And we have hyperbolic cosine root x over root x. What would make the most sense for you is root x, because if you take the derivative of that, okay, remember that's the same as x to the 1/2, so the derivative would be 1/2 x to the minus 1/2. So that's the same as 1 over 2 root x. 1/2 x to the minus 1/2 is 1 over 2 root x dx. That's almost what we need. We already have dx over root x. So if we multiply both sides by 2, we would have 2 du is equal to dx over root x. And that's what we need there. So we can rewrite this as 2 and then integrate hyperbolic cosine of u du. Okay, so let's look at our sheet and see what the antiderivative of hyperbolic cosine is. It's hyperbolic sine plus c. So that's going to be 2 times the hyperbolic sine of u plus c. You put u in the problem, you got to take u back out. All right, what is u? It's root x. So 2 hyperbolic sine root x plus c. And you could try to take the derivative of that to check. Hopefully you will just believe me. I don't know, take the derivative, I don't care. Okay, so pause the video, I'm about to erase, and we'll do another example. Okay, this is example 42. All right, and that is take the antiderivative of hyperbolic secant squared of 2x minus 1 dx. So we'll let u be 2x minus 1. Du is just going to be 2 dx. So half of a du is equal to dx. So we'd have 1/2 out front. Take the antiderivative of hyperbolic secant squared of u du. Look at our sheet. The antiderivative of hyperbolic secant squared is hyperbolic tangent. So I'm going to have 1/2 hyperbolic tangent of u plus c. So that's 1/2 hyperbolic tangent of 2x minus 1 plus c. You can check that by taking the derivative. Might be worthwhile to try that on the test. So a lot of them work this way. You might have 1 or 2 on the homework problems where you have to think a little bit harder on it, but we'll cross that bridge when we get there. All right, so there's your examples for integrating hyperbolic functions. Let's look at taking derivatives of inverse hyperbolic functions. Okay, so finding derivatives of inverse hyperbolic functions. Goodness, that would be like, you know, we've been doing arc sine, arc cosine. Well, there's inverse hyperbolic as well. So you're just going to use the sheet. So it is a plug and chug kind of thing. So one example should do the trick. Let's look at example 54. guess we're on page 401 by now. Look at us go. All right, and we have y is equal to inverse hyperbolic tangent of x over 2. That is a mouthful. Let's look at our formulas. So we find inverse hyperbolic tangent of u. It's u prime over 1 minus u squared. Okay, it's kind of like what we did here on the other side of the sheet. Okay, so u prime over 1 minus u squared. So u is going to be x over 2. U prime would be 1/2. Okay, so let's plug it into the formula. So y prime is going to be 1/2. That's u prime, right? Just plugging into the sheet, over 1 minus u squared. So that's x over 2 all squared. Now we want to just clean it up. Try to simplify this fraction. So 1 minus x squared over 4. All right, so that's going to be, let's move this whole bottom up one level next to the 2. So that would be 1 over 2, all right, times 1 minus x squared over 4. Now the book will do a lot more than that, but I'm going to just let it go right there. So I will write down some of the answers that I would accept so that you're not confused by the back of the book in a minute. So that is the lecture for 5.10b. But don't leave yet. Let's talk about the homework for just a second. Okay, so the homework is on page 400, 37, 39, 40, 41, 53, 55, and 57. Now on your schedule sheet, it also shows 75 and 76. You do not have to do those. Those are calculator, and since we are not at school, we're just going to skip over those two for now. You won't have to do two like that on the test. So again, you don't have to do 75 and 76. I have a hint for number 40. You can use an identity. All right. When I say identity, I'm talking about these identities. Use one of those identities to try to simplify your situation, and then you can perform the calculus on it. All right, so use an identity. Now let me look at the answers, and I'll write, I believe number 37 in the back, the answer from the back of the book is good. 39, same thing. The answer to 40, right, since that one's not in the back of the book, is minus hyperbolic secant x plus c. All right, the answer to 41, the answer in the back of the book is fine. 53, the answer in the back of the book is fine. But 55 and 57, the back of the book goes a little crazy. So 55, I'm fine with secant squared x over the square root of tangent squared x plus 1. And if you want to try to boil that down to secant x, you can. That's the answer that's in the back of the book, but I would accept that. And then 57, 2 cosine 2x over 1 minus sine squared 2x, I would accept. The book uses identities and simplification to boil that down to 2 secant 2x. I wouldn't require that on the test, but if you want to try it, give it a go. And again, 75 and 76, don't worry about it. That'll do it. That's the last lecture for this particular section other than test review. So I will see you on the test review videos.